Good morning, everyone. Good morning, Kotlin Conf Day 2. How are you all feeling? Good? Yeah? Good? I want to hear some, are you good? Okay, great. The party was too good last night, huh? Yeah, I get how that feels. My name is Huyen Dao. I'm an Android developer and a Kotlin developer. And today we're going to do a little dissecting of Kotlin. By the way, folks in the back, is this visible okay? Give me a nice wave if you can see it all right. Great, thank you so much. I think I see you back there. So, we're going to dive into a couple, maybe a little more depending on how much time I have, of the latest stable and experimental features. And I don't just want to tell you what the new features are and basically how to use them. I love, especially when a new feature in Kotlin comes out, to dissect it, to really understand how it works, why it exists maybe to some extent. And by understanding that, I hope always to not just write better Kotlin, more idiomatic Kotlin, but also to kind of just learn some things just generally about maybe designing my own software, designing my own APIs, how to structure my own code in a better way. So we're going to talk a lot about some things that are part of the Kotlin evolution and enhancement process. The keeps, if you've never read a keep, I actually encourage you to do so. Some of them are actually less intimidating than others. And it's a wonderful part, I think, of it's part of what makes Kotlin so wonderful, is this kind of very transparent, very community-forward feedback loop. So I'd encourage you to go and check them out. But we're going to talk about a couple of things. I'm going to cheat a little bit. I know that we've been in Kotlin 2.0 for a little bit, but I wanted to talk really quickly about something that you probably have seen as a warning in your IDEs, and that is the enum entries function and also the accompanying enum entries interface. So there is a keep for this. This was actually stable in 1.9.20, and there's a lot of interesting things here, I think. So it's a little bit of a simple example, but I think it's good if we start off simple. So, if you have been using Kotlin for some time, I'm sure most people in this room have already written an enum class. They are, the analog to Java enums. So there is that, lovely Java interop story that has been so helpful in the adoption of Kotlin, yeah? And, you probably have done code like this at some point where you are trying to understand or grab a list of these predefined values that this enum class can take. And if you have been doing it lately, you might have seen a warning like this, where this is being replaced by a property rather called entries. So why is this being, why is it warning me that why is this method being deprecated? Well, let's go into a tiny bit of, let's get to know values a little bit before we say goodbye. And so basically, this is actually a quote from the Kotlin language specification. And enum class, just like a lot of things, are part of that backwards compatibility Java interop story. And it's really interesting that because of this desire to interop with Java, the return type of values is actually an array. And I have to admit, when I first started using them, I kind of completely forgot that arrays are mutable in Java, which already kind of like a red flag, right? Because we're kind of used to thinking about things in very mutable ways these days with Kotlin. And it very explicitly states that because of the mutability of array, every time you call values, a new array is allocated for that call. And we can already kind of feel, oh, this is getting very uncomfortable. And in fact, in the keep itself, and let me see if I can pop this open. In the keep itself, there actually is a whole section about the different problems that have arisen from this. And in fact, I think it was a really good lesson to me that, a lot of times, especially in these days, I feel like we often worry about pre-optimizing, right? Because we have so many wonderfully performant tools and Kotlin itself as a language. So sometimes we get to a state now where I worry maybe I shouldn't make a new class for this. Maybe I'm worrying too much. Maybe I need to focus on other things like architecture or anything else. And what I think is really interesting is this is evidence of death of 1,000 cuts still is a thing, yeah? Because here we have this method in the Spring framework, HTTP status resolve, and it called HTTP status.values, which is that enum values on HTTP status, and it was actually causing performance issues. It was causing benchmarks to not do well because of that really consistent allocation. And I just think that's a wonderful, if a little bit frightening wake-up call to maybe where we need to kind of, where Kotlin also needs to go to not just, maintain that Java interop, but really take the language to better and safer places, because that's kind of part of it. So this is where entries comes in. And so entries is just a new property on enum. So it's a property that's generated for each enums class, and there's a kind of an accompanying enum entries class. So what is the big deal about these classes? Well, to answer that, I want to actually just kind of dive down a little bit and see what's going on behind the scenes. And we're going to take what I like to call a bytecode break, because we're going to look at the bytecode that's actually compiled when this code is compiled. So I'm actually going to go over here. I'm actually going to go into the builds folder, classes, where is show category, and we're going to actually show the bytecode. And actually, I usually decompile the bytecode into something that looks like Java, because this is very intimidating, but it actually is not so bad today. So if you can see here, this is the bytecode that actually gets, this is the bytecode from the compiled class. And you can see here, this is, again, where values is running into trouble. There is a static, values reference somewhere, but every time this is called, it's invoking this clone function and creating that mutable array, and where all the trouble comes in. But if I look for get entries, oops, lost it. Where did we go? There we go. If we look at get entries, you can see that it's a much nicer looking set of instructions for us. It's literally just getting that static value and returning it. So there's no extra allocation, so you can already assure ourselves that, yes, this is much more performant than the previous values function. And there's also kind of to mirror the enum values, which is a generic function that takes a type of an enum and then gives you that previously mutable array of possible values. We now have enum entries as well that shows, again, that list of possible values for the enum. So let's get to know enum entries a little bit. I'm sorry, let me squeeze that just so it's not quite cut off. OK, so enum entries is actually an immutable sealed interface that directly inherits from list. And when I first looked at this, I understand why we need to move away from values because of all those allocations, but why this new interface, right? Why do we have this? Why isn't it not just a list? And if you read the keep, there's actually a really great explanation. And the summary of it is that the list interface, I'm basically quoting, does not represent well the intended meaning of entries being a list of all existing enum entries. So a little bit of detail. So say that you call so say you call entries and it returns a list, right? And you take that from that call site and you shove it somewhere else. That list that you have taken from entries and use somewhere else in your code, it's actually lost context, right? There's no way of looking at this list of enum values and knowing, explicitly that it's a list of all the possible values. It's just a list of enum values. You don't really know, and so it loses that context, which could promote some risk or just kind of again, incorrectness. And not just that, say as a developer, I wanted to write a utility that is on top of this object that is the idea of all the possible values in an enum. I can't really do that on just a list unless I specifically have a precondition, or I just trust really hard that you gave me the right input into that function. And so that is why, in part, why enum entries was created. And it's sealed because it's a lot safer. Sealed class hierarchies have to define all of the implementations of it in the same module, so it kind of keeps it nice and tidy inside the standard library. And it guarantees that enum entries can be extended in a backwards compatible way without having the compiler to generate extra code. And I just think that's really interesting. Just that little extra thinking that I had to do is why is it this way? So the key takeaways I want you to take from enum entries is that, number one, use entries, of course, and you can build logical extensions that you need if you need to build logic on top of the idea of all the values of an enum. But also that compatibility with Java was important, but so are bugs, fixes, and improvements, as we all know, and that the language has to progress. Kotlin's got lots of great adoption, as we can see from all the people in this room. So now the language is moving towards being safer and cleaner. And also, death by 1,000 cuts actually happens. I feel like so many times we think that it's okay, this won't show up, and then it shows up in a magnificently awful way. And also that paying attention to semantics and intention is a good thing. And I never even thought about the idea that, hey, when I take this list, this array of values, and use it somewhere else, it's lost a lot of context, right? It's lost information. And that maybe it's worth it for me to make that extra class just to keep that context going along with my data. And I love that. I love that so much. So that's why I want to talk about enum entries. But we'll get to some kind of more recent, juicier stuff. So let's talk about context parameters, the feature formerly known as context receivers. So you might have been following the story of context receivers over the last few years. They were actually introduced in 1.6.2.20, I think that's right. And there are keeps for these. They're actually pretty meaty. Like when I first opened these, they were a little scary. But actually, I would really encourage you to read them because there actually are a lot of wonderful discussions of the different designs of syntax that the team went through. Very concise, but like, if I'm not understanding it, it's a me thing. It's a me problem, but there's a lot of wonderful explanations about why the decisions were made. There was even in this one, like coding style recommendations. So I really recommend you to read them if you're curious about these new features. So I just tricked you a little bit because I said, let's talk about context parameters, but I want to really dissect this because I think there's a lot of really interesting background and things to think about that can lead us to thinking, okay, what kind of broader like lessons can I take from rather than just simply using context parameters? All right, so everybody loves scope functions. And what are the scope functions? They're the when, sorry, not the when. They're the apply, also, let, run, all these like wonderful functions that you probably fell in love with, like me, when you first started using Kotlin. And these functions, and I didn't actually know they were called scope functions at first. I just called them by name. But yeah, like now, oh, scope functions. And that's absolutely perfect name. These are functions that put you in the context of or in a context with an object. And what's different is how this object becomes available inside the block and what the result of the whole expression is. It was so funny because I think when we first got introduced to Kotlin, or at least we did in the Android community, there was a lot of wonderful talks and panels about, okay, when do we use which one where? By the way, if you go to kotlinlang.com these days, there's actually a very elegant table. There's a lot of great examples. I love it. So I won't go into that, but just to know that it's there, and it just makes me feel very warm and fuzzy that it is. But yeah, they're not too, unfamiliar. But I wanted to take a look at these because I want to take a look at how these create this scope, and really it's creating a context. Yeah. So I have here. I love heist movies. My favorite heist movie recently was a vampire heist movie called Abigail. So that's why this example is like that. But yeah, let's say that I have a heist object and I'm initializing it. I might use something like the apply function on my heist object. So as you can see here, there's this little this that the IDE is hinting to me. What is this? So this is that heist object. And it has become, it's almost like the apply function creates a small world, right? Where I guess you could say that that heist object is the center of that world. And in fact, because it is the this inside of that block, I can call member functions of that heist without qualification. So, and that's like a reason we tend to use like these methods, right? We have a lot of like member calls on the same object and we want to clean it up. That was like a big thing that we thought about and used it for when we first started using Kotlin. And there's also, which is similar, but rather than having it be the this, it's just another parameter, or rather another object inside of that block, right? And you can use it to refer to it, although you should really use a variable name to disambiguate, but that's fine. But yeah, so these functions are really just creating these little worlds, right? These little blocks where a certain thing is happening, a certain context exists. And there's let, there's with, there's run. I actually just recently, I never really used it myself, but there's two runs. There's the run that maybe you're used to using, which is this one, which is an extension function. And again, extension functions being one of those things that I think whenever I ask someone's favorite Kotlin feature, it like wins a lot. And so you have this run method. It's a run function, rather. It's a extension function, and then similarly, you can run some kind of code in it. It returns a value. Now, there's also this is my kind of cute fact that's not really relevant, but there's actually a extensionless run, which I thought was fascinating, that you can use when maybe you want to pass an expression around. So it's interesting, like extensions, right? So I'm talking about building scope and building context with these scope functions. Extensions have a lot of that going on as well, extension functions, when we first learn about them, oh, they're a great way to add, a member or a property to a class or interface that you don't own. You don't have to inherit. You don't have to use like some pattern like decorators. And what's really interesting is that if you think about your extension functions, right? If you think about, this extension function like this, right? This declaration, or actually, let's look at this declaration. You have the extension, the thing that you're extending, and this is called the extension receiver, and then you have its declaration. And inside of this declaration is a context it's in context to that object that is being extended, in this case, my heist object. And again, this notion of inside this declaration is a little bit of a different world where certain things are true or certain things are available. And that's kind of the power of it. And that's where, you can, again, call, just like with the scope functions, you can actually kind of call members of this extended type without qualification, yeah? So I always think it's interesting to kind of look at how I'm using code. And I think we've all done this like 6 months down the line and gone, oh my God, what did I do? And so I've done a function like this, or an extension like this rather, many, many times. So this is an extension property. And it's saying, OK, is this nullable string possibly an account number? And after a while, honestly, after doing this I think I wrote my first Kotlin file in like 2016, I was like, is this really worth an extension function? And I think that's always a good thing to ask is like, what is the benefit of this? And what am I really saying with this? Now, the extension function is actually pretty sexy, and I like it very much, right? It's a very nice way of packaging this logic. But it's a top-level function. So in my code base, this extension property exists for all, everywhere in my project. But I don't know if every string in my project could possibly be an account number. Does that make sense that it's a top-level function? Maybe not. And you could probably argue that the semantics of this, the meaning of this, are a little bit muddled, and also just maybe it's not such a great thing to always stick everything top level, as I know was like kind of my palpitations when I first started using Kotlin. I would never stick anything in the top level, and now I'm sticking everything in there. But I think it's always good to kind of retrospect and kind of look back on what we do with these things. All right, so let's move on to receivers. All right, I've talked about receivers a lot. So here's where we're going to go down into the deep dive. I actually ended up in the Kotlin language specification document a lot for this talk. It was a humbling experience, but I think it was really illuminating because it helped me kind of see things a little bit differently. So what is a receiver? So according to the Kotlin language specification, every function or property that is defined as a method or an extension has one or more special parameters called receiver parameters. And I think that's so interesting because I think a lot of times, especially looking at an extension function, you don't really think of that receiver as a parameter so much as you think of, oh, I'm just extending it. It is the object, right? It is not a parameter. It's like the thing that I'm, focusing on. But really what a receiver is the object, and it's the object receiving a call or property access, but really it is an input to that extension function. In fact, if I go in, I'll go back up real quick to the extension functions. If I take another bytecode break, and you've probably already seen this before, but if we look under the hood at any of these extension functions, we can see that, yes, indeed, and you may already have seen this yourself, that the magic that is extension functions really is just, in the compiler, and that under the hood, indeed, the receiver is a parameter. Here's this. Here is a thing that I'm calling that on. Yep. And so, I just think that's so interesting, right? So this receiver is really a parameter, both kind of contextual, both theoretically, but also literally in the bytecode. So, if you ever wondered if there's a fancier name for dot operator and safety operator, they're called navigation operators, along with the double colon that helps you with function references and the class literal. I just thought that was interesting. And so the null safety operator's formal name is safe navigation operator. I thought that was interesting. But basically, just to throw a little more definitions at you, I thought this was really fascinating. It blew my mind a little bit when I read it. I intuitively understand it, but it kind of blew my mind when I read it. So when calling such a callable using the navigation operator, the left-hand side is called an explicit receiver of the call. That makes sense, right? It's literally the thing that we're calling it on. And in addition to that explicit receiver, each call may indirectly access 0 or more implicit receivers. And what the magic power of that implicit receiver is this. If an implicit receiver is available in a given scope, it may be used to call callables implicitly in that scope without using the navigation operator. So that very clearly, that was like a lot of the magic that was in the scope functions and in extension functions is this like little secret sauce that is hidden away with much language in the Kotlin language specifications. So it's really funny because I think I usually just think of it as the this. I think of it as a thing that allows me to call things without qualification and type a little less. But it's really funny to see how many implicit receivers are. I mean, like, I see implicit receivers everywhere. And I'll give you an example of it here. And please, please, please don't write code like this. This is why you shouldn't really nest the scope functions. And it's handy to have on if you go do option return on Mac. Sorry, I don't remember what the Windows one is. There's implicit receiver and parameters hints. Please turn those on, especially if you write code like this, but actually just don't write code like this. So I'm looking at with here, right? And this with is creating my context. It's creating a certain world, right? Where we'll say that, and these are 3 data classes called 1, 2, 3. And 1 has a reference to 2, 2 has a reference to 3. I don't know what I was smoking when I wrote this example, but that's what you have. And so yeah, we have this first context, right? This context, where 1 is the center of that universe, right? It's the this. And to just kind of save myself some explaining later, the term that we could call this inside of here is the default implicit receiver. It is by default what has that power of being able to have its callables called without qualification. Now, what if I go ahead and take that 2 that is inside of my 1 and also give it a scope function? Now what's happened? Well, a second kind of world, a second context has been created inside the first one, but things have changed around a little bit. Now the this inside of this is 2. Sorry, the this inside of this context is now 2. It's now the default implicit receiver. And it's not that the previous implicit receiver went away. It's just now having to need having to need a little qualification, and that's what you can use, say, these labeled thises for to refer to other implicit receivers, and then so on and so forth with my third scope function. Please don't do this. But so I was like, that's amazing. When I read like 0 or more implicit receivers, I'm like, where are they hiding these implicit receivers? Right here. And I just think that's like a really interesting idea that there can be kind of like these hidden parameters, or not so hidden if you turn on the hints, like to each of our callables. I think it's just absolutely fascinating. So again, these kind of contexts, right? They create these like nested. There are these nested contexts now that I'm creating, and Kotlin actually defines rules that prioritize like the implicit receivers at each level, and it's always the innermost receiver that has the highest priority. So it gets to be just it's fabulous this self all by itself. And then if you're lower priority, unfortunately, you need to be labeled, which no one wants. That's terrible. But it's not so bad for the implicit receivers, I suppose. All right. So it's really interesting because I've been using scope and context a little bit interchangeably. I've been trying to be careful, but I think this is another thing that kind of really came to my mind thinking about context parameters and trying to figure out what they do and how they work, is that we really should be careful about just separating out scope, which has a lot to do with visibility. It's about, okay, inside of my little inside my little block of code here, what of the outside world can I see? But context is a little bit different. Context is a lot about the data, the objects inside of it, and maybe how that block relates to them. And if you're a coroutine fan, it's very much similar to the difference between coroutine scope and coroutine context. And let's take this, all this information that we have that I've spewed at you about receivers and implicitness, and let's talk about a way that maybe we can layer more intentionally this interesting mechanism of kind of accumulating these implicit receivers, and let's talk about extensions as members. So real quick, how many Android developers do I have in the house? Please raise hands. Okay, not bad. If you have been using Compose, which I hope you are, you might see some of this context in Compose since it is a Kotlin-based GUI toolkit. Now, I also watched Indiana Jones and the Last Crusade, so that's why this example is like that. But I want to take a look at a little class. Let's pretend that we're finding the Holy Grail. That sounds like a lot for a conference, but say I have this sealed interface where I have the sealed interface for a Grail. There's a true Grail. There are false Grails, which you shouldn't drink. It's a bad time. And imagine that I have this thing called the Temple of the Sun, which is in the movie where the Grail is stored. And I have regular member functions for that temple. But what I have here is, oh, hey, extension functions. And they're functions that are extending an object, or a class, rather, that is separate from the class that they're declared in. And when I first saw this, I remember distinctly seeing this, and I think it's some compose code. I'm like, what is happening right now? What is going on? Who's driving the bus right now? And these are what are known as extensions as members, and there actually is a page in the Kotlin docs for them. And I think this is really fascinating because this is where playing with implicit receivers and extension functions and scopes and context can really come in. So what I've done here is I've actually created, an extra requirement to call these extension functions. Let me go back to my code. So what's really fascinating is if we look into here when I call this. Okay, so I have this block. It's a with, and the implicit receiver is Temple of the Sun, that temple object. And inside of it, I can call member functions without qualification, sure. But then I have this, which is one of those extensions as members, and I can actually call it inside here. And in fact, I have to call it inside here, because I've declared that extension inside of another interface or class, that becomes required context to call it. And so if I call this method outside here, outside of this block, it's not valid. It's not recognized. You can't do it. So it has now given scope to my extension function. And just to kind of give us plenty of words to talk about all these receivers with. So this receiver, the one that you're calling the extension on, is the extension receiver, easy to remember. There is now another receiver associated with this, and it's specifically called the dispatch receiver, and that's this. That's the implicit receiver of this with, that Temple of the Sun, and it is the implicit receiver. It is that required object you need to be in scope of, or in the context of, that is associated with the scope of where that extension member was declared. And I love this because they are required, and now it's actually, become, part of this call. And just to see what's going on under the hood here, I would like to take another byte code break, and we're going to see what is happening under the code. Because again, I was very confused on who's driving the bus. It's like, does anyone know where we're going? And if we go down, let's find that live forever function, great function, or maybe, I guess it depends on your perspective on whether you want to live forever or not. And where is it? Oh, actually, sorry, I went to the wrong class. If we go back to my Grail class, decompile the bytecode, there it is. Okay, live forever. Okay, where are you? There we are. All right, so it's really funny because underneath all of this insane syntax, there is just this function. And just like any other extension function, the receiver basically got tacked into the parameter list. So under the hood, there's not a lot crazy going on here. It's just letting the compiler give you some superpowers, giving you some more ability to kind of structure your code in a different and hopefully interesting way. All right. So I love these because the keep actually refers to these as contextual declarations. Is exactly what they are, right? They are declarations that exist within the context of something else. And they basically require that some particular scope, some particular context must exist in order for you to call that method. And not only is it a nice way to, kind of, I guess you just make it a more accurate representation of what my logic is trying to do. It also cleans up that top level, that top level, all those top level functions that I was just throwing in there willy-nilly. So if I look at this, let's consider that example of my is account number, extension again. So again, it's here. It's free floating out in top level space. Like it could be applied to any string, which doesn't seem quite right. Or if I know that this is very specifically used for, say, a profile object, a profile interface, I can use it as a member as extension. And now this function has a place to live, right? We really only care about account numbers when we're talking about profiles. So now we've made this a contextual declaration, and we've given it even more meaning, and that meaning stays attached to it. It won't let you in unless you acknowledge that it needs a profile to live in. I absolutely love that. It's a great tool. But it does have some limitations. And I think that's why it takes some of us, if you haven't seen this before, because Compose hasn't foisted it on your eyes, there's a good reason for this, I think. And that's because there's actually no dedicated syntax to actually specify that dispatch receiver, that context. There's no explicit syntax to do it, right? Because I had to kind of sneak it into a class declaration, or sneak it into an interface definition, really. So because of this, we actually have to use not necessarily language features, but the scope functions to make this work. So how would I actually call this? So let's go down here. So I have a method that wants to call that, that contextual extension that I have. And if I go ahead and just try to call it, of course that won't work. But if I can just create a context that has it in it, if I do just good old lit with, then here we go. I've created a context that has that dispatch receiver in it, and I can go ahead and call that function, and we'll go ahead and make that code not break. So there are quite a few limitations to this, as you can see, because it is such a very specific syntax and situation. Of course, extension members, normally we like to say, hey, you can extend a class that you don't own, but in this case, it's tough because you need to declare, if you want to use extension members, you need to declare that extension inside of an interface or class that you do own. So it's hard to do this with third-party objects, and there's no way to declare a contextual top-level function with this. So it might be that, hey, maybe I have that isAccountNumber method, but I don't actually own the profile, but I still would like to attach this to that context. I can't actually do it because there's no way to do it currently. If you ignore that now context parameters exist, there was no way to do that. And finally, only one receiver can define a context. There's no syntax for multi-receiver context. And I don't know if you're that kind of person that after using let for a while to be able to say assert the nullness or non-nullness of a certain object and do a bunch of stuff on it. I don't know how many of you have also thought, man, it'd be great if I could do that for a bunch of things at once. I don't know. I've thought of that many times over the last 9 years, but there's no way to do that, right? We're stuck with basically right now one receiver to do that. So I'm going to talk about context receivers, and I want to be careful talking about it because the context receivers actually are the first draft of this feature, and the keep has been revoked. But I think there's some interesting things here to see in the evolution of this feature. All right, so they were first introduced in experimental in 1.6.20, but because of feedback from the community, and that's why it's really awesome, to kind of use experimental features, not in your day-to-day work, just play around with it, and kind of give feedback to the team, because I actually really like the changes, but we'll talk about those in just a second. So context receivers are a way of filling that gap of not being able to have just a syntactic way of saying, hey, this function needs a dispatch receiver. This function needs to have some context to be called. And so the way that you create a context receiver is by using the context keyword and then in parentheses specifying a list of types. So there were a few restrictions on receivers. You couldn't have any repeats of types. And no pair among the receivers could have a subtype relationship, like one could not be a subtype of another. And it was actually interesting, though, because context receivers could be applied in a lot of different places. I'm not going to tell you them because they're not really relevant anymore, but context receivers could be applied to functions and members, including extensions. And so each context receiver, when it's declared, inside of that declaration that it's attached to, it actually becomes an implicit receiver. And you can call their members without clarification, or qualification, sorry. So here, I'm actually now rewriting some of my methods or adding some methods using now this context receiver. So here I have that context keyword, and I have here just the type. And so inside of this declaration, I now have a context where this is that receiver that I specified inside of that list. And going down and down and down. And here we go. I can actually now create a extension method that is an extension method. So I get that nice extension functionality, but that is kind of refined or just kind of like specifically only usable in a certain context. And again, one of the benefits of doing this is that if you would like to be able to call member functions of that context without qualification, you can. And this is actually So it's a little hard to see, but this is actually a member function of the temple. And then, I mean, you always have to log things. I don't know what we'd be logging inside of the temple. I kind of cross streams a little bit with logging my archaeological adventure. But if I had a logger here and I wanted to log that I poured the water into the grail, I can actually call debug, and debug is a member function of logger. So you can start to see that you're going to get a lot of member functions with this older syntax. You can see you're going to start having a lot of members from different interfaces and different classes, all being called without qualification, which sounds fun and then sounds terrifying after you think about it for a little bit. So I feel like that's kind of obviously one reason why this old syntax went away. And what we can do still, though, is actually, let's take a look here. So this is a context receiver on a member. Now, another problem that would come up is, well, what if there are members of all of my, what if my context receivers have members with the same signature? How do I resolve those? So if I have this toString method, right now it's the toString of this outer user repository interface. With context receivers, if you had to disambiguate, you would have to use labeled this. This is labeled this, labeled die, labeled this. I'm not sure what the plural on that is. But as you can see, just more ambiguation that could be difficult to deal with. And just to kind of wrap it up with these, with the context receivers. Oops, sorry, everything's folded. How can we make this call work? This call to that fetch all users. So I had 2 context receivers with that function, and basically this is what I would have to do, which I told you and begged you not to do, is to start nesting, these scope functions. So, but it is handy, right, to be able to define these very specific contexts where things can or cannot happen. Now, we really should be talking context parameters. I want you to kind of remember those lessons, but absolutely forget that context receivers exist, except for the purposes of learning and history. And we're going to actually talk about context parameters real quick, and I'm going to do that. And if you are using context parameters, they are experimental. So you'll have to add a compiler arg. You're going to have to resync Gradle and hope it goes well, because you're doing this all live. And we think it did go well. OK, cool. All right. So context parameters are super, super similar, but they have some really important and I think helpful distinctions. So context parameters are very similar, but instead of just having a list of types, you're going to have a list of name type pairs. So it's basically a parameter list. It's just a parameter list that lives not inside the function signature, but above it. And so these are now context parameters. And you can write very similar functions to the ones we were writing before, but now instead of having implicit receivers, you have these names that you can use to reference these context parameters, and which, while it might be a little more typing, is a lot more clear. And you still get that benefit of kind of forming a kind of requirement around these extension or these contextual declarations. And you can put them on a top-level function, on a method of a class. Let's see, what else do we got? You can do them on top of extension functions, and you can do them on extension properties. OK, and I want to let me see if I can get a little bytecode break in there again and see what happens. Let's see what's happening under the hood. Just to show that, again, a lot of this is compiler magic and not magic that you need to incantate and wave a magic wand for. And as you can see, for example, in this one, those context parameters they're parameters. They're literally parameters inside of the bytecode. And I love that. It says what it is on the tin. You know what I'm saying? The syntax is different, but it's literally just parameters. So context parameters are a little bit complicated when it comes to member properties, class properties, or just properties in general. So there's a few restrictions on using them with properties. So let's see. You cannot use context parameters on properties with a backing field. And you can only use them on properties where you explicitly, have the getter and setter spelled out and with no initializer. And there's an explanation about this in the keep on this, but it has to do with when that context parameter gets read, and then the impact it would have on the getters and setters. So So there's a few kind of restrictions on parameter names. They cannot repeat. You can actually, though, use an underscore, just like in any Lambda where you have a parameter that you're not using. You can actually slide in an underscore in there for any context receiver, or sorry, context parameter. That's why I trying to forget them. You can actually use them. So what does it mean, though, when we specify an underscore? This means that context receiver is specifically just there as a requirement. It's just there to bring context, and that we don't intend to use it, or to call any members upon it. So again, going back to my isUserAccount extension, I can do that here, right? I can specify profile as a context parameter, but pass it no name because I don't need to access anything else in the profile. There is a method called context of, where if you have something like this context parameter, and for some reason you change your mind in the middle of the code and want to bring it out, you can. I don't know if I'm supposed to be telling you this and if you're supposed to be using it, but it exists. And I'm not sure whether it's a vestigial piece of context receivers, or this might just be something that I construed kind of going along with this. But just to let you know, it's there. I just found it. The IDE suggested it to me. It's not my fault. And so the context and input receivers in a scope are the context of that scope. So what that little underscore is doing when it's kind of saying, hey, I need to be here, that's part of what is called context resolution, which is really just a process where the compiler looks at the context parameters in a callable and basically looks at all the scopes around it and starts filling in those context parameters. It tries to find one, compatible, compatible parameter, and it sticks it in. That's all that this process does. And I think this process of context resolution and some of the complications with context receivers and all the implicit receivers, I feel like that again, keep it very, very interesting, a little bit like here on my level. So it feels like that this is part of that reason why the design was made, the design change was made. But yeah, what blew my mind is that context parameters can be applied to function types. So you can write code that looks like, oops, not that like that just yet, but like this. So I have here a higher order function, a function that takes a function as a parameter, and I can actually append a context parameter to it before, if there's a receiver here, be here. But yeah, I can append it to that function type. Crazy, right? So you can even bring this kind of contextual requirements to function types and function parameters. And as you saw earlier, because I left it in from when I last did practice this talk, you can use type aliases with them as well. So that's really interesting. And then the way that this is called here, it's actually kind of sucking up the context that's available from here and using it to call that data loader that has also those contextual requirements. Pretend there's real code here. And this is what it looks like when you call it. You still have to use either the with, but there's also another option. There's actually inside of a block, not like outside of a function signature, but inside of a block, you can actually do, and this is not, I think this is going to be slightly incorrect. So this is also why you should be careful with using experimental functions. I had this function actually, shoot, sorry, let me finish typing before I talk. I actually had this function called context throw me an error because sorry, there. You can actually do, sorry, I'm running out of time. You can actually do this. This is a method that allows you to basically state, hey, these are context parameters that need to exist for here. They don't, and that's why I'm having trouble right now, is that they don't actually function as implicit receivers, so you can't call members on them. It just exists to kind of fill in those holes from context resolution. All right, I'm going to erase all that. So it's just because I'm running out of time. OK, there we go. There are some coding notes that go along with context receivers. Sorry, I'm trying to wrap up. Don't do this. If something could be an extension function, just make an extension function. This is similar to how extension functions got misused, but basically there were some coding styles in context receivers which I think apply. Basically, if you have a function that is acting on an object, just write syntax that calls it as a function on that object. Don't do something like this, right? Don't use context receivers to simply pass parameters. And this is kind of where you need to kind of think for your, like, kind of like, it's kind of your mileage might vary, but yeah. If something could just be a simple parameter, make it a simple parameter. Don't make it a context. It's literally an input. Let things be input sometime. And I think the rule of thumb that I'll leave off on when to use these is that, and it's in the keep for context receivers, but I'll tell you here, is that if this context parameter could provide additional ubiquitous context for actions, it might be good as a context parameter. Like, ask yourself, if this could be a really good, like, global top-level scope in a small application or a small architecture, like, again, logging, analytics, things like that, it might be a good use case. And finally, make them interfaces, because you don't want to be doing like something like this if you have one of those massive contexts where you want everything, loggers, analytics, all the things in the kitchen sink. Make them interfaces so you can combine them to one and then pass them as a context parameter. And I just want to say, like, I encourage everybody to like look into these things, like, and kind of take lessons not just about how to use these things, but maybe it just inspires you to be more intentional. Maybe it inspires you to introspect things that you're doing and decide whether they are idiomatic for either Kotlin or yourself. Both are good. But I'm sorry I'm running a little over. Thank you so much, and enjoy the rest of Kotlin Conf.